Okay, so as I modeled and as I talked about with our note-taking, we've started with Big Idea 1, and I'm going to call this Big Idea 1A, which is states of matter. And as we look through this, what we're going to consider is the questions, the key questions that I see on the page called Big Idea 1, Density and its Properties. So the first thing I'm going to do over here in the margins is where I'm going to put my date. So for example, this will be 8/17. And then this middle section will be where I put my drawings, diagrams, and other. So I'm going to use the margin that's already given on the page, plus draw in a margin for myself, and we will go from there. So the questions I want to think about when I look at this, the first two questions are, how do you think particles, atoms, molecules of fluids are differently arranged than solids? How do you think particles are arranged in air or other gases? And then while you're answering those, you want to consider some of these pieces. Are there patterns? Are they close together or far apart? What do you think is between air particles, empty space or something? If there's something between the particles, does it have mass? What's going on with that? And what characteristics must we deal with here? So, as we start with this first big idea, our first topic for this class is the models that we're going to use. So, models in physics are a key piece to all that we do. And because we want to simplify in such a way that we can understand the way the object behaves, the way the materials behave, but we don't want to get so bogged down that we're trying to trace every single little item that's happened, we're going to think of these as different models. And so the first model that we use in Physics 2 is the idea of a continuity model. And so we have to decide for ourselves continuity model versus particle model. And you'll notice I'm putting this in my middle section. My middle section is my thinking part, my ideas, what I'm going to do, and the drawings that I'm going to make. And so what we want to start with is, how do we look at fluids? We know from chemistry that objects really have a lot of empty space. Each atom is a nucleus, and then the electrons are around it in a cloud, and all that is happening, there's empty space. So the particle model is, we will use this one. It's used when we want to identify the behavior of the atoms. We want to look at atoms and molecules as if they were independent pieces. So they are separate pieces or separate objects under our consideration. So in real life, if I was to look at, for example, a solid. Let's say we had a solid like, I don't know, your desktop, for example. What we might see if we zoom in, and zooming in would be using the particle model, we would see some sort of structure to this material. And because I don't want to get too outrageous and take too much time, I'm going to draw a pretty simple little structure so that I can see how these atoms and molecules are going to behave with one another. And so I've got, there's my structure. Now, I don't know necessarily yet what these spaces in between are, but I can see that clearly that there are spaces in between each atom, but the atoms are connected somehow that give it this hard structure, this solid idea. Where with liquids, I might want to go with something that's a little bit different. And so how am I going to illustrate a liquid? So my first item of concern with a liquid is If I push on a liquid, it'll flow out in some other direction. So maybe what I'm going to draw is the atoms sort of touching each other, but not all the other guys. And they're kind of spread out in different places so that if you push on one of them, they can all wiggle around and wander to a different location. And our first idea for gases might look something like I started with here. Gases are just kind of wherever they happen to be, and we can see plenty of empty space. So a gas, if I'm using the particle model, a gas will have lots of empty space. A liquid will have empty space, but the empty spaces move. The empty space will have empty spaces around connected particles. So in a gas, what we might see is we might see this guy goes here and this one goes over there, and so there's this freedom to roam. Whereas in a liquid, we might see it roll over here and then around this one and around that one and move around. They do move around each other, but it's much more like a shuffling of particles while we all stay in contact with one another. The solid is rigid with empty space, just like the other ones. But the empty spaces stay fixed. But the empty places don't move around. So maybe in your mind, when you first start doing your notes, here's your big idea 1, states of matter. You've got your first big idea, and here's the models that we're going to talk about. And now you've drawn some pictures over here. And in this column, this is the column where you want to give evidence for each one of these ideas. Okay, and I'm going to get to that one in just a minute, but let's talk about what the continuity model says first. The continuity model says that we have no empty spaces. In liquids or solids. So in a solid and liquid, for both solids and liquids in this model, the way we know this is not true, okay? But you have to remember that sometimes you have to start with a simpler picture to be able to answer the question. So the solids and liquids are going to have these edges or boundaries, and we get different shaped objects, and some of them are kind of weird, and sometimes they kind of wiggle out, and they look like a bunch of molecules, sort of, if you will. You can have some really weird ones if you like, just as long as you have membranes sort of between each little chunk. And we would show maybe different colors, like maybe these are some of these are shaded one particular dark color, and then some of these have some stripes. And that indicates to us that there are different maybe materials or different size atoms or something, or we do some weird things. But as we look through here, we can see that these individual pieces, they have their own sort of personality, and yet there's no gaps in between them. So we're going to give the evidence for that on the right-hand side, so hang on to that. But with gases, we're still going to sort of give that same picture. So even though we know a gas looks like the empty space that we see over here, in this model, the continuity model, liquids and solids don't have any space. Gases, the way we're going to think about them is they have no empty space, no empty spaces between parts, but each piece is, and this is not a technical term, is squishy. So what is some evidence for the continuity model? So I'm going to come over here. Continuity model. Water out of a hose pipe. Looks like and feels like solid mass of water. We don't feel any gaps in it. Okay? We don't see that the flow of water has holes in it, that there's gaps or spaces between the particles. And yes, understand that the particles are really, really tiny. But what we learned in chemistry is that there are huge empty spaces in atoms. And so what we're saying with the continuity model is you can't tell that there's any space in between atoms. Okay? So what are some other models? So what about solids and liquids? Continuity. Think belly flop. How does water feel if you belly flop? It feels and acts like a solid surface. Some of you have done this at some point in your life and you know how painful it is. And so you've got this situation where belly flop makes you feel like liquid is more like concrete. You don't feel any compression or softness to the water. And gases, when you look at gases, you can squeeze a balloon without it bursting, and it feels in the air or the gas or whatever you have in there, the gas just shifts around. Okay, so you feel that there's a compression. Something is squishy about the gas, but the fact that it's squishy doesn't mean that there's a gap or a hole. It's not like in the classroom you walk in. There's no places in a classroom where you have no air. You don't have to worry about, oh, I walked in the back corner and now I can't breathe because there's no air back there. So walking around in air feels solid. It feels like the air feels like it is everywhere. And so that's kind of what we're looking for our continuity model. Now, what is the evidence that we would have for the particle model? Well, most of the evidence for the particle model comes from chemistry. And so when we look at chemistry, when we zoom in the particle model, a solid does not change shape. So it feels like there must be something holding it, something prevents a structural change. But with a liquid, liquids take the shape of the container. And so the liquids, somehow there's some room for them to move around. They can move around each other, but they don't lose contact with one another. So there is empty space, but the empty space must be moving around somehow as the particles jostle and move. And you can see that with boiling water. Some of the water boils, it turns into a gas, and then you see a gap where water used to be. So somehow there's some spaces in the liquids, and in gases, we know there's empty spaces, but like I said, most of our particle evidence is going to come from, not from the way we see, touch, and feel it. So the particle model comes about because we see, let's say this with the particle model. The particle model, you must be able to look into an object You must be able to look at the atomic structure to talk about a particle model. So what might my summary idea for this particular piece look like? Well, at the bottom, I'd summarize it by this. Here's our summarize the idea. The particle model is used when we look at the interior atomic or molecular structure while the continuity model is used when we look at an object's mass as a whole. So we're going to use a continuity model when we look big picture, when we look at a blob of water, when we look at a tub of water, when we look at the gas in a balloon, when we look at the atmosphere, we would be using a continuity model. If we look inside and we want to see, oh, is this carbon dioxide or is it carbon monoxide? Well, then I have to zoom in closer and say, oh, I see 2 carbons with only 1 oxygen. Or I see 2 oxygens with 1 carbon. Or I only see 1 carbon and 1 oxygen. So as I see these, I have to kind of look at the ideas. The particle model is going to be when we look at small groups of things, interior structure, molecular structure, and chemistry is very strong on looking at particle models. And then physics, we tend to look at all of our liquids, solids, and gases as if there's really no space between the atoms. They're all there, but gases have the special property that their atoms and molecules are squishy, where solids and liquids, their atoms and molecules are not squishy. They cannot shrink the space in between them. Okay, so that's where we're going to stop for our first day, and I hope this helps you, and it helps you see how the model of the notes is going to work. And if I think I'm going to need to use another page, I will literally just flip over to the next page, and I'll keep going on this same big idea. So I'm going to set aside a few pages for this idea, and then maybe the next idea, and so forth and so on. But if I feel like I've got all the big pieces together, like you should in this piece, we're going to summarize the idea, and then we'll move on, and page 2 will be Big Idea 1B. Okay, thanks for listening, and feel free to ask questions as you get stuck.